let's start to our webinar. Let me introduce myself. My name is Volkan Öğüt. I'm a civil engineer, and I've been working in Prota Group for 12 years. In this webinar, let's talk a bit our agenda today. So first, we will talk about our overview of products. Then I'm going to continue with the webinar content. And after that, we will talk about, actually, I will show how you can insert these different foundation types on different levels. And at the end, I will take your questions. By the way, I will take questions at the end, and you can write your questions via our chat box. There's a chat pane in GoToWebinar, so you can write your questions from there at the end of the webinar. So, as you know, project delivery process includes different parts such as modeling, design, analysis, fabrication, detailing, and BIM. So, ProtaStructure is an all-in-one software that accomplishes all these stages, and you can complete all these different project delivery stages with a single software. ProtaStructure Suite consists of 4 different softwares. First one is ProtaStructure, that you can model, run finite element analysis. You can design your members regarding to the selected code. Then you can send your model to the ProtaDetails environment to obtain the reinforced concrete detail drawings. Or if you have steel members, you can send to the ProtaSteel, and you can create your steel connections. You can obtain fabrication details and bill of quantity as well. You can also share your BIM, actually ProtaStructure model with other BIM platforms such as Autodesk Revit. Also, SAF format can be used for Nemetschek Group's softwares. You can also export your model, structural model, to the other structural software such as SAP, ETABS, and Tekla. Okay, so in our webinar, I will show how you can add slab patch panel for the bottom of columns. Then we will continue with the stepped foundation and elevator pits. Also, we will model a step foundation and elevator pit. We will talk about horizontal soil springs in Raft foundation. And lastly, I will show how we can add column drops in foundation. So let's briefly see these features. So in ProtaStructure 2024, you can use a base reinforcement in the entire foundation and calculate additional support bars at the these slab patch regions. For example, as seen in this image, we created slab patch panels, patch zones actually, and the software has generated additional reinforcement as seen in here. Also, you can now model and analyze foundations at different elevations and elevator pits with the ProtaStructure 2024. Actually, we were able to do this before, but we enhanced this feature significantly. You can now, we are able to assign horizontal soil springs, which is crucial, especially for step foundations. And if you want to set this subgrade coefficient ratio, you can get into the options and change this value. I will show in the live webinar. You can also add column drops in foundation, especially time to time we may have some problems about the punching check. So to create a more economical foundation design, you can add these column drops instead increasing the foundation slab thickness for the whole, actually for the whole foundation. So let's see in action. So I would like to show these features in my sample model. Let me open the 3D view of it. So as you see, we have a step foundation over here. I mean, I will create a step foundation over here, and there will be actually an elevator pit surrounded with these shear walls. And also there will be an elevation difference, which is around 1 meter. Okay, so let's just start to model this. So once you go to the story 0 is our foundation story. So if you want to add pad footing, strip footing, whatever you want, you need to go to the story 0 if you want to add a foundation member. Okay, so let's select plan view, and I'm going to select the story 0, which is my foundation story. So as you see, there is no a column projection, a column section projection in the foundation story because we didn't assign any support. So let's just go to the modeling tab, and let's create a support for this column. So I'm going to create a fixed support. To do this, you can click on this plus green plus button, and of course you can actually key in any name that you want. Okay, and as you see, all directions and rotations are restrained. So I'm going to click OK button, and what I'm going to do, I will just select all these columns and click on the column table command. So what I'm going to do, I will just change all support type at once, just like this. So now you can see the support signs on the bottom of columns. Okay, so let's also change the elevation, bottom elevation of the columns. Okay, so what I'm gonna do, I will go to the first story and I will select all columns in this case. So we can again use the column table for this purpose. So I'm gonna insert 1000 millimeter to increase the bottom elevation of these columns. You can clearly see that we have changed the bottom elevation. I'm gonna do the same for shear walls, but before this, there's one column that I want to change the elevation. So you can simply go to the Geo tab and change the elevation from here. Geo represents the geometry. Okay. So you can see that we have changed the bottom elevation of this column. Now I'm gonna select these shear walls that I want to change the base elevation. This one, I don't want to select this one, so let's deselect this. Okay. Okay, so I have selected all these shear walls, and what I'm gonna do, I will again use member tables to change the bottom elevation. I'm gonna do the same for the other node of the shear wall. Okay. Now you can clearly see that all except this elevator pit, all columns and shear walls have different elevation, which is 1000 millimeter higher. Of course, except this part. So now I would like to insert also my strip footing beams. Okay, so let's go to the story 0 plan view, and now actually after support definition, now we are able to see these columns sections in story 0, actually projection of column sections. So again, let's just select the foundation beam, and we can insert beams to define strip footing. But please make sure that you change the correct elevation, otherwise you will not be able to insert strip footing. Okay. Okay. If you would have a shear wall over here, you could just insert a separated beam just for under that shear wall. Okay. So in 3D view, you can clearly see that all beams are inserted. Also, we have changed the elevations just like this. So now I would like to run the analysis because I have assigned new supports. So I need to reanalyze the structure. So let's just click on the building analysis. If you want to continue with the column and beam designs, and if you want to reselect all bars, you can select these options. But in my case, I will not, because I don't want to spend time for the column and beam design because we have limited time. So that's why I will just run the analysis and I will directly go to the foundation story. Okay, I think in a couple seconds the analysis will be ended. Okay. So now what I'm gonna do, first I will select all these beams. Let's just click OK. I'm gonna go to the story 0 plan view, and I will select all these beams to insert a strip footing. What you can do, you can just right click and select insert strip footing command. So in here you can click to design envelope, otherwise only the factorized GQ combination will be considered, but generally I suggest you to use design envelope to consider earthquake combination as well. So if you have if there are some connections to the nodes from the other direction, you can insert to this column. If you insert a value for this column, a footing width might be a bit lower. Okay, so you can also change subgrade coefficient or footing bar size from here. It's up to you. You can change the footing depth. We are automatically calculating the footing width. This is the minimum value. If you want, you can change this value from the actually options. I will show them. If you need cantilevers, you can also create some cantilevers by inserting the cantilever spacing. Okay. Once you click the design button, you can see the diagrams, and let's just, by the way, it's probably lower than minimum value, so it didn't change even in here. However, I will use finite element method for this strip footing, so I will just continue with this strip, actually finite element method. Now you can see strip footing just like this. You can also see this in 3D view. So I will just model a rough foundation over here. So let's continue with the modeling tab, and I'm gonna click on slabs. Our slab thickness of my foundation slab thickness will be 60 centimeter. Concrete cover is around 50 millimeters. If you have a load, you can assign it from here. There might be, let's say, for example, residential floors. Okay. So what I'm gonna do, we have different slab insertion methods. Once you click on this arrow button, you will see. So generally, I'm using pick points, but if you have a closed region, you can use also beam region command over here. So let's start with the pick point command. Okay, you just need to show the corner of the foundation slab, and that's all. So the foundation has been inserted. Of course, it will be, if you go to the 3D view, you can see that there's a gap between the columns and this foundation slab. So what we need to do, we need to just change the elevation of it. If you don't change this elevation value, you may have an error during the finite element analysis. Is there any? Yeah, I will just answer this question at the end of the webinar. Okay, let's continue. So after inserting the elevation difference, make sure that you are applying this Z elevation difference to the analytical model by this checkbox. Okay. So this is really critical, because if you don't check this option, and if you only insert the level value, it will be shown correct in 3D view, but in the analytical model, you will have problem. Okay, so let's continue. I'm gonna create a small slab over here. Let's just insert again by using pick points. Okay. For cantilever part of the foundation, I'm gonna use type 12. So the cantilever length will be 1 meter. So simply, I will just draw this cantilever from node to node, and then the slab will be generated just like this. Okay. And in here, we will have a slab of elevator pit. Okay. So what I'm gonna do, this time we can use beam region. You just need to, of course, we can select type 1. You just need to pick the closed region, and the slab will be generated on the clicked region. Okay. By the way, we will not have elevation difference for the slab, so we can make the level as 0. Okay. So now you can see that we have created our Raft foundation with our elevator pit. Just one last thing that I generally suggest: before you go to the analysis, foundation analysis, I suggest you to check the slab table. For example, for cantilever part, I forgot to assign apply Z levels, actually apply Z elevation to the analytical model. So, for example, if you just continue by unmarking these checkboxes, definitely you will get an error during the finite element analysis. So, what do you need to do? If the elevation has changed, just click these checkboxes, and that's all. Okay. So now what we can do, we can create our slab strips. So to create a reinforcement detail, we need to generate slab strips over the foundation. So let's select the finite element strip type and then fixed band strip. Here we have a fixed band strip option. So you can simply draw this fixed band along the foundation, and we can determine the limits of this actually band via using this button. You can see over here. So simply I will just, because we have an elevator pit over here, so the reinforcement detail will be changed. So that's why I will just draw this band till the edge of this shear wall, just like this. Okay, so the elevation is at the same level till 1W9 shear wall. So I will just draw this slab strip till here, okay? Till here. So let's just draw this and change the limits by selecting with this button. Okay. Let me do the same. I think I couldn't pick the correct nodes. Okay. And here. Now you can see that the boundary limits has been applied to the slab strip. Once again, I'm going to do the same in here. Okay, just like this. And for the, because the reinforcement detail will be changed due to the elevation difference, so I inserted a separated band just for this region. Okay. So I'm going to create another strip along this, actually along this axis. Okay. Please do not draw the strip from the axis, otherwise you may have problem with reinforcement details. So, I mean, because some of our users are just snapping to axis and draw the slab strip, don't do this, otherwise you will have problem with the reinforcement details. Okay. So I'm going to create on the Y direction a slab strip for the Y direction. By the way, you can change the number of slab strip from here. I always start from 1, but of course, if you want, you can continue from the last number if you wish. Okay. And I'm gonna do the same over here because I just want to create my slab strip till here. And we can again specify the border of this band strip. As you see, we can quickly create these strips. It can just take a couple minutes, and that's all. I'm gonna do the same for this part. If the spacing is changing or elevation, I suggest you to create a separated slab strip for that region. Okay. And lastly, we have a part over here. Foundation part. So I just need to specify this boundary limits from here. Okay. So now what I'm gonna do, we have a valid analysis, then we can go to the foundation analysis from here. If you want to include column sections in finite element model, you can have more economical design. But if your column is so close to slab edge, I don't recommend this setting, actually this option, because you may have some analysis problems. You can change soil subgrade coefficient from here. And if you want to a faster analysis, you can use sparse solver analysis from here. But if you have an error, please unmark this option and reanalyze the foundation to detect the exact position of the error. Okay. So once we select the floor mesh analysis, the software is warning that I have a foundation on the upper level. So yes, I know, and I want to continue. We have added this warning because time to time some users are doing this by mistake, so that's why. Okay, in the by the way, for strip footing, I want to use finite element results. Okay, so in the display analytical model, we can review our reinforcements or soil pressure. Generally, what I do when I design my foundations, first I go to the contours. Okay, and I check my soil pressure under envelope of the combinations. Okay, so if you're, for example, in my case, from the geotechnical report, it was around 280. So actually, the soil pressure is satisfying the geotechnical limits for this project, of course. Then what we can do, we can check the reinforcements actually. For example, X direction, bottom reinforcement, design bottom reinforcement. There's a slight difference between required steel area, this one local, and wood armor one. So wood armor is considering the torsional effect of the foundation slabs, is a method generally is being used in the Asian territory. So of course, in options, if you want, you can consider wood armor, or if you don't want to actually use this method, you can simply deactivate it from options. Okay, so we have AST1 bottom reinforcement area, you can see over here. And if you want, you can just transform this legend values to the known reinforcement values. To do this, you can go to the user-defined contours and activate the user definitions. Okay. In here, what I'm going to do, I will increase the, for example, contour count. So let's just make it 8. And what I'm going to do in, sorry, I want to use the bottom one. So let's do this in bottom. Okay. So again, we can change the contours. Okay. And what I'm going to do in here, I will just add some actually contour values regarding to my reinforcements. Okay. So let's say that we have a base reinforcement fee 12, 20 centimeter. So if we add again one more fee 12, 20 centimeter spacing, then we can quickly use this contour value in my legend. Okay, just like this. Or for example, just feet 16, 20 centimeter spacing. Maybe feet 12, 15 centimeter spacing. Okay, I'm just changing these values with the known values of these reinforcements. Okay, and maybe it might be feet 12, 250. Okay, so once you click OK button, you can clearly see that our legend has been updated regarding these values. Okay, these reinforcement values. So what I'm gonna do, I will just export this contour values to the foundation view. Okay, actually, once you arrange this view, the software is automatically saving the view in the display part here, visual integration. So first I'm going to close this foundation model, and we can again actually activate the story 0 plan view. So in visual integration, you can clearly see that these contours has been transferred to the visual integration. Okay, so before I add my patch panels, I can use these contours to determine the patch sizes. So let's just update steel bars, okay, before the patch panels. Now you can see that we have our reinforcement, but now we will add a patch reinforcement for these columns. Okay, to do this, we can simply select our column members, and then once you right click, you can just select the drop slab patch panel command. In this case, we will add patch layouts. So our patch sizes will be 2 meters by 2 meters. Okay. And we can clearly see that my patch region is covering this, this contour region over here. Of course, if I want, I can slightly create a smaller patch size, but in this case, I will continue with this patch pattern. So now I'm gonna select the slab strip, okay, slab strip just like this, and click on the slab strip design. So once you select this strip and slab strip design, you will see the assigned patches for the relevant columns. Okay, so you can arrange the base reinforcement from here. For example, let's say that we have phi 12 20 centimeter spacing for the top and bottom, and once you reselect all bars, additional reinforcement will be automatically determined. So let's just click OK button, and you can see the patch reinforcements over here. As you see, the software just created a straight patch reinforcement. So what I need to do, I need to change this patch reinforcement as a bobbed one. Okay, so on the left, instead of lap, I'm going to select bob option to create to bend this reinforcement just like this. I'm going to do the same in here. First, we can select the patch, right click, select patch panel, and we can now change the left end, right end with the bobbed option, just like this. Okay, now we have clearly seen the how we can assign patches, insert a reinforcement. Now I'm going to insert some column drop members. To add a column drops, you can select the column members just like this with the control button of your keyboard. Then right click. Again, you will see drop slab patch panel command. At this time, I'm gonna use drop layout. Okay. So normally our foundation thickness is 60 centimeter, but for the patch region, I will use 80 centimeter thickness. So let's, again, I'm gonna insert 2 meters for each direction. Okay, you can specify the eccentricity via this button, or you can just simply key in this eccentricity values. So if you look at in 3D view, you can clearly see this column drop regions just like this. And especially Raft foundations, what we have to do, we need to actually check the punching of these columns. So let's just click on column punching check. You can click on hatch floor area to see the zone for the punching, and we can simply click to calculate button. So we have a detailed report. If you have any problem, you will see in the notifications. As you see, for this 1C6 column, the slab thickness has been taken as the slab drop. Okay, so we can create more economical foundation design using this slab patch panel and slab actually column drops on foundation. You can also add reinforcement to this drop region. For example, I'm going to add phase 16 20 centimeter spacing, just like this. And once you click OK button, the relevant reinforcement will be drawn as seen in the screen. So I'm going to do the same. You can simply select the diameter and spacing from here. Okay. So now what I'm going to do, I will design my strip footing. So for this purpose, we can go to the actually design tab, and in here you will see foundation beams. So you can just select the beam design batch mode, and we can reselect all bars from here. Once you double click on it, if you want, of course, you can play with this reinforcement manually. For example, instead feet 14, we can use 3 feet 20, just like this. Okay. By the way, we have a really detailed report. You can print all design forces, bending design summary, shear design summary. Okay. You can print all these summaries. We have also added code clauses in our new version. For example, you can see the code clauses over here. Okay, and let's just click OK button. So by the way, let's go to the options, because I would like to show horizontal soil springs. So in the foundation options, you can see foundation heading over here. In the foundation options, we have a horizontal subgrade coefficient ratio. So you can simply check this option. Generally, 1/3 or 1/4 value of the vertical subgrade will be okay. So you can use the default value. By the way, you can play with the minimum steel bar sizes or maximum steel bar sizes from here. You can set the distribution bar size, another steel bar spacing, or other setting from here. Now I would like to rerun the analysis, but this time I will consider the foundation and superstructure together. So I will simply merge the foundation model with the superstructure. By the way, we have really detailed reports, so I will show after the analysis. During the analysis, if you have stepped foundation, you may have axial load warning, so you can ignore and skip this warning, because we only take the first story when we calculate when we compare the axial loads. So because in our in our model, some bottom column nodes are finishing on the first story, top of the first story. So axial load comparison can be ignored for such a model. Okay, so if you have step foundation, you can ignore this warning and skip with OK button. Okay, because we only take the first story to check this axial load comparison. Okay, so once you get into post analysis and display analytical model, you will see that we have merged the foundation and upper structure successfully. If you simply click on the node, one of the nodes that has soil springs, for example this one, you can clearly see that lateral springs are considered as well over here. So let's just close this analytical model. I will just show a couple things more. Let's talk about a bit reports, because we have a really detailed foundation report. We have enhanced this part significantly. For example, once you let's just use envelopes. Okay, so once you generate the report, you will obtain soil pressures, slab design values, reinforcement values. All these different parameters are being combined in the same report. So yeah, actually I can admit that this report is pretty good if you compare with the previous version. So you just need to wait a couple seconds, because there are so many nodes in the foundation. So software is preparing the report by taking a value from each node. Okay, so once I generate this report, you will see that we have really detailed foundation parameters in this report. You can see all soil pressures, reinforcements. Let's just wait for just a couple seconds more. Okay, you can find soil parameters, summary report, met foundation properties. Also, you can see the, for example, soil pressures, finite element contours. All these values are being shown in this report. So you can just export to the Word or PDF. You can also If you want to see just soil pressures, you can use geotechnical report. So in here we have a soil pressures for each slab in here. Okay. So one last thing, I would like to show the details in ProtaDetails software. So I'm going to send this model to the ProtaDetails environment. So the ProtaDetails will be shown in a couple seconds. Then we can create a drawing. For example, I will just draw foundation story in this case. If you want, you can add form plan side dimensions. If you want, you can insert to sheet. So just like this. By the way, all these reinforcements are intelligent. Once you click on this reinforcement, you can get into the properties of the reinforcement. You can play with the length of the rebar, for example, 2500 millimeter, and it will be automatically updated in the quantity table over here. I would like to also show the strip footing detail. Just like this. You can see the sections, okay? If you want to create the quantity table of it, you can do this as well. You just need to select all and select the quantity table. Of course, you can quickly add this to the report, add this quantity table to the report, okay? So let's finalize the webinar. So now everybody can reach to the our knowledge base without any fee. So you can just simply check our reference manuals, ProtaDetails, ProtaSteel. So it's open to everybody now. Before only the users who has a maintenance would reach this help center. Now everybody can reach. In our website, you can review our white papers, blogs, webinar recordings, tutorials. So I suggest you to visit our website. And please subscribe our YouTube channel, and you can see the latest videos in our YouTube channel. Also, we are sharing our webinars, some trainings. By the way, please follow us from our social media accounts. You can see our social media accounts in LinkedIn, YouTube, Facebook, Instagram. Okay. If you would like to receive an offer, you can send an email to the globalsales@protasoftware.com, or you can visit our website. Thank you for joining us today, and see you at our next webinar. Thank you. Bye.